morning, students. Welcome back to P.N.AMERSEY e-learning classes. Today we are going to start our second semester chapter. Students, today we are going to start our chapter number 11 and topic of the chapter is force and pressure. This is your first part. Students, let's start our chapter with the topic force, a push or a pull. First, I will explain you what is a force. When we want to open a door, we have to push the door handle with our hand. And when we want to close the door, we have to pull the door handle with our hand. This means that to move an object, it has either to be pushed or pulled. A push or pull on an object is called force. This is the definition of force, student. You must listen to me carefully. A push or pull on an object is called force. The direction in which the object is pushed or pulled is called the direction of force. We open or close a door by applying force. Let's continue this topic, students. When we push the door to open it, then we apply a force on the door in the direction away from us. And when we pull the door to close it, then we exert a force on the door in direction towards us. Force are used in everyday actions like pushing, pulling, lifting, stretching, twisting and pressing. For example, a force is used when we push, it means kick a football. A force is used when we pull a door. A force is used when we lift a box from the floor. A force is used when we stretch a rubber band. A force is used when we twist a wet cloth to squeeze out water. And a force is used when we press the brake pedal of a car. The fallen leaves of trees fly away with wind because the force of the wind pushes them away. Even the roofs of some huts fly away during a storm because the force of strong winds pushes them away. And when we fly a kite, we can actually feel the force of wind on it. Before we go further, students, we should know the meaning of the term interaction as used in physics. Interaction means a reciprocal action. Interaction involves in two objects. In interaction, each object acts in such a way as to have an effect on the other object. In most simple words, interaction means to act on each other. Now students, let's learn the topic. Force is due to an interaction. An interaction of one object with another object results in the force between the two objects. In other words, a force arises due to the interaction between two objects. At least two objects must interact with each other for a force to come into play. If there is no interaction between two objects, no force can show its effect. This will become more clear from the following examples. Suppose a man is standing behind a stationary car. Since there is no interaction between man and a car, no force acts on the car and hence the car does not move. Now suppose man pushes the car with his hands, due to which the car starts moving. When the man pushes the car, there is an interaction between the man and the car. During this interaction, a force arises which acts on the car and makes it move in the direction of applied force. Students, please note that the man has to push the car to make it move. Hence, the two objects which are interacting for the force to come into play and show its effect are the man and the car. So, students, from the above example of a stationary car and man, only man is capable of applying force to the stationary car. Now, if both the objects are capable to applying force on each other, then the interaction between them can be of pushing or pulling. For example, the two boys as shown in the picture are interacting and applying force on each other by pushing each other. On the other hand, the man and the cow, as shown in the picture, are also interacting, but they are applying force on each other by pulling each other. In this case, the man is pulling cow and the cow is also pulling the man. So, students, you must have understood that force is due to an interaction. Now we will learn force has magnitude as well as direction. An adult man can apply large force on an object, whereas a child can apply only a small force on an object. Your father can apply more force than you. This means that a force can be larger or smaller than the other force. The strength of a force is expressed by its magnitude. The magnitude of a force is expressed in the SI unit. SI unit means standard unit of force called Newton. 1 Newton is the force which can make an object of 1 kilogram mass to move at the speed of 1 meter per second. Along with the magnitude of force, the direction in which a force acts is also to be specified. This is because if the magnitude or direction of the applied force changes, the effect produced by the force also changes. When two forces act on an object, then two cases arises. Either the force act in the same direction or the force act in opposite directions. Students, it is clearly seen in the slide that the force is applied in the same direction, then it is being added up. See, if the first boy is applying X Newton force and the second boy is applying Y Newton force, and they are applying the force in the same direction, then the force is being added up. It means X plus Y. In second picture, two boys are applying the force in the opposite direction. Suppose first boy is applying Y Newton force and second boy is applying X Newton force, but they are applying the force in the opposite direction. Then the force is being minus or subtracted. That means X minus Y. Now let's learn. If the two forces applied to an object act in the same direction, then the resultant force acting on the object is equal to the sum of the two forces. In other words, when two forces act in the same direction, their effective magnitude increases. This will become more clear from the following example. Suppose there is a heavy box which one man can move only by pushing it very hard. Now, if two men push this heavy box in the same direction, it becomes much easier to move the heavy box. This is because when the two men apply their forces to push together in the same direction, the two forces add up to provide a much bigger force, and this bigger force can move the heavy box very easily. Students, as you can see in first picture, that two men are holding a sofa set, but they are applying the force in the same direction. First man is applying 25 Newton force and second man is applying 20 Newton force. Then their force is being added up. It means net force becomes 25 Newton plus 20 Newtons, that is equal to 45 Newton towards the right side. Similarly, children are playing and they are applying force in the same direction. Then their force is being added up. But student, if the two forces applied to an object act in the opposite directions, then the net force acting on the object is equal to the difference between the two forces. In other words, when the two forces act in opposite directions, their effective magnitude decreases. This will become more clear from the following example. Suppose there is a heavy box lying on the ground. Let the two men push this box from opposite directions. That means one from the left side and other from the right side. Assuming that one of the men is stronger of the two and applies a large pushing force than the other man, we can say that the box will move in the direction in which a large force is applied by the strong man. The box will, however, move very slowly in this case because the net force acting on the box in this case is equal to the difference in the magnitudes of the two forces applied by the two men, and the net force is small. As you can see in the picture, that the force is applied on the opposite direction, then the net force acting on the object is equal to the difference between the two forces. First boy is applying 10 Newton force and second girl is applying 6 Newton force, but their force is in opposite direction. Then the net force will become 10 Newton minus 6 Newton, that is equal to 4 Newton. Similarly, in second picture, a small dog is applying 10 Newton force and a big dog is applying 12 Newton force. Then the net force become 12 Newton minus 10 Newton, that is equal to 2 Newton towards the right side. Now the third condition is if the two forces applied to an object are equal in magnitude and act in opposite directions, then the net force acting on the object is 0. 0 means nil. Since the net force acting on the object is 0 or nil, in this case the object does not move at all. It remains in the same position. For example, if the two men push a heavy box from opposite directions by applying exactly equal forces, then the heavy box will not move at all. It will remain where it was. A familiar example of this case of equal forces acting in opposite direction is provided by the game called Tug of War. Tug of War you must have played in your school, students. In this game, two teams of persons pull at a rope in opposite directions. Members of both the teams try to pull rope in their direction. When the two teams pull the rope equally hard by applying equal forces, the rope does not move in any direction. At this point of time, the two teams are applying equal but opposite forces to the rope, due to which the net force acting on the rope is 0 and hence the rope does not move. Actually, the equal and opposite forces applied on the rope cancel each other effect. Ultimately, the team which pulls the rope harder by applying greater force wins the game. Now students, according to third condition, if the two forces applied to an object are equal in magnitude, just like in tug of war, the two forces applied on either side of the rope are of same magnitude, then the opposite force will become 0 or nil. So we can see that if the two forces applied on an object are equal in magnitude then and act in opposite direction, then the net force acting on the object is 0 or nil. That you can see in the picture. In third picture, opposite forces are of same magnitude, 5 Newton, another one is also 5 Newton. Then the net force is 0. That's all for today's session, student. We will meet again tomorrow with the second part of this chapter. Up till then, goodbye and thank you.